Instantaneous velocity, that is what we are going to study, children, how to find the instantaneous
between x and t is known for the motion. Let's understand how to calculate instantaneous velocity using an xt graph.
So from xt graph, usually in a vehicle, the speedometer shows that instantaneous velocity. See, speedometer will show the instantaneous velocity of the vehicle. This speedometer, it will show the instantaneous velocity of this vehicle. Every time, every instant, velocity is changing. That is speedometer shows. And from a graph, how will you find instantaneous velocity? Xt graph. What's meant by xt graph? Position. X means position. T means time. Position, time graph. Where is time taken? X axis or y axis? Time.
X axis.
X axis. X axis. Position, y axis. That graph is known as position time graph. And here we are going to find, see heading, you see, instantaneous velocity. We are going to find for instantaneous velocity. See, this is the equation for instantaneous velocity, and we can see how we are getting it. This is the equation for instantaneous velocity. We can see that. And first you have to plot the graph. So from the graph, how will you find instantaneous velocity? That is what we are going to study.
Let's understand how to calculate instantaneous velocity.
Okay, this is the xt graph plotted, children. And nature of the graph, it is not a straight line. So what type of motion is this, children? Curve. Xt graph is a curve.
Non-uniform.
Non-uniform motion.
Yes, correct. It is a non-uniform motion. And by finding the slope, what we get? Slope.
Instantaneous velocity.
Average velocity. We are getting average velocity by finding the slope. Let us see that.
Using an xt graph, we first mark a point P on the graph at which the instantaneous velocity of the body has to be found.
So we have to find instantaneous velocity at the point P. When it is at P, at that particular instant, that means instant you can find by drawing a perpendicular to this time axis. That is the time now that we can note. At that time, what is its velocity? That is what we have to find out. When the body is at this position, what is its instantaneous velocity? That is what we are going to find. You see.
Mark 2 points, P1 and P2 on either side of P. Join points P1 and P2. Find delta T and delta X.
Children, here in order to find the instantaneous velocity, different steps I am explaining. First, you take 2 points on either side of P, P1, P2. Then join with a straight line and find the slope of that line. That means that change in position. When it is at P1, this is the position. When it is at P2, this is the position. And what are the corresponding time? When it is at P1, this is the time. The time axis you can see. Suppose it is 4 and this point, this perpendicular meet at 7, 7 minus 4. That will be 7 minus 4 will be 3. That is the time interval. And here if it is this is 100, this is 50, then 100 minus 50. This displacement delta x. So by drawing these perpendiculars, you can find out the change in position here. And you can, by drawing the perpendicular to the time axis, that difference of these two values will give the change in time interval. So from that we got delta x and delta t. What is delta x by delta t, children? What is delta x by delta t? Average. If it is distance, speed we get. If it is displacement, we get average velocity. Average velocity we are getting. Okay. So displacement by time, average velocity. Next step you see, we are taking some other points Q1 and Q2. near to P, we are considering two other points on either side. Either side of P, you consider 2 points. You can see that.
Delta T is reduced, we get lines Q1, Q2, etc. On further decreasing the value of delta T.
So what is done here, children? Here, time interval is reduced. Time interval. Earlier, the blue line, you see, that is the P1 and P2 time interval is this difference. Blue lines are corresponding lines drawn from P2 and P1. That difference is the time interval. Now, is the time interval increased or reduced, children? When we take Q1 and Q2, time interval, is it reduced or increased?
Reduced.
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 Now, next case, we have reduced the time interval taking the point Q1 and Q2. So, what happened to displacement? It also reduces. Time interval is reduced, distance covered by the body also reduces. So, and like that, interval is reduced. Next step you can see.
We finally get one line.
Another 2 points are taken. Very near to P, 2 points are taken. For example, R1, R2 like that, 2 points are taken very near to P. Again, we have reduced the time interval. Time interval is reduced. And at last you see, again we reduce the time. Like that, if we reduce the time, what will happen to displacement? Displacement also reduces. And interval, for example, time interval 1 hour, half hour, 10 minutes, then 10 seconds, then at last that interval is reducing to, at last before it tends to 0, what is it that, children? Interval. We are reducing the interval. Interval reduces, at last it reaches to what, children? Interval, when it is reduced, at last it becomes what? Not approaching, it approaches 0 interval, approaches to 0 interval. 0 interval means it is actually instant. That instant, there is no interval then, only instant. At that particular instant, what is the velocity we are getting? So, when we take an interval delta x by delta t, we give average velocity. But when delta t tends to 0, t and ds, when delta t approaches to 0, what it gives? Average velocity gives instantaneous velocity. Interval is reducing to 0. That time the velocity will becomes instantaneous velocity. That is the definition of instantaneous velocity. We can see
the tangent to the curve at point P. The slope of this tangent represents the instantaneous velocity at point P. Slope is represented by tan theta as shown in the graph. This graphical method of finding the instantaneous velocity at any point is cumbersome. Therefore, we generally use the numerical method using calculus for finding the instantaneous velocity at any point. Let's solve a problem using the...
Okay, so here we have seen, we have reduced the time interval and at last what we got at instant, when it reaches to an instant, just by drawing a tangent to that point, draw a tangent to that point and find the slope of that line, draw a tangent and find the slope of that line, that will give instantaneous velocity. So, children, that method, it's it's slightly difficult, but an easier method is there in mathematics. Mathematics, there is an easier method to find the instantaneous velocity. That is what we are discussing here. This process is very difficult process. Time interval approaches to 0, that all values you have to write. Delta t, this interval, what is the displacement? Again, delta t, in textbook you can see a column for that, they have made a column. And delta t again reduced, what is the displacement? They note, at last time interval when 10 to 0.00 like that, such a small value interval reduced, what is the delta x by delta t? That is calculated, that is our instantaneous velocity. That process is a very difficult process. So, instead of that, we take an easy process, that is in mathematics, that a branch of maths is there, differential calculus. In that we find the first derivative of position with time. So you can see here, I will explain what process we have done here. We have found delta x by delta t to find the average velocity. And next step, what is done? Time interval is reduced to 0. See children, I will ask question after this. See. So first we found delta x by delta t. For what? For finding the average velocity. It is not instantaneous. It is average velocity. Next step, we reduced the time interval to 0. Average velocity we found. Next average velocity we found by reducing the time. So we put a limit to the time and then find the average velocity. And that is what we got as instantaneous velocity. So limit delta t tends to 0. When time interval is reduced to 0, tends to 0, not 0 children, tends to 0, what is the average velocity? That is instantaneous velocity. So I will ask question. How many of you understood? Let me see that. Muhammad Nehal. Okay, children. What is delta x by delta t? What is delta x by delta t, children? I will ask to Adinand. Adinand, tell what is what
average velocity.
Is the numerical
average.
method.
Okay, average velocity. Let's go on.
The position of a particle that moves along a straight line is defined by the relation, further decreasing the value of delta t with, where x is expressed in meters and t in seconds at any point.
Okay.
Let's solve.
Okay. So here numerical method we are explaining. Delta x by delta t is average velocity. And then how we determine instantaneous velocity? What limit is given? Aditya PS. Aditya, after getting average velocity, how will you determine instantaneous velocity from the graph? Aditya not answering. Arjun, how will you determine?
Time interval tends to
Tends
0.
to 0. Very good. When time interval reduced to 0, we find.
ടീച്ചർ അത്
Okay.
ധനീഷ് വെയിറ്റ് ചെയ്യണ്ടെന്ന് പറയുന്നുണ്ട്
Danish.
മീറ്റിംഗിൽ ആഡ് ആണ്.
Nihal is there. Nihal, come, go like that. But Danish, I can't see. Participant, nobody is there. Danish net may be weak. So here, time interval tends to 0. We again find delta x by delta t. That means average velocity. Then we get instantaneous velocity. So when time interval is reduced to 0, you find the average velocity. That becomes the instantaneous velocity. So how will you read this, children? Instantaneous velocity v equal to limit. This is limit. We are giving the limit to the time interval. Limit delta t tends to 0, delta x by delta t. Delta x by delta t is average velocity. In average velocity, you give the limit to time, that is delta t tends to 0, time interval tends to 0. What is the average velocity? That is the instantaneous velocity. So how will you define instantaneous velocity, children? When time interval tends to 0, the average velocity becomes
Instantaneous velocity.
Instantaneous velocity. That is the definition for instantaneous velocity, and that is mathematically written in this manner. Instantaneous velocity v equal to limit delta t tends to 0, delta x by delta t. And in differential calculus, it the same thing. It is written in this manner. v equal to dx by dt. This is change in position, this is the time interval. In differential calculus, the same thing is written in this manner. First, that means dx, that is the change in position, dt, that is the change in time, dx by dt. So, it is also read as first derivative of position. First derivative, d by dt means derivative. When you do problems, it will be easy for you. I will give you problem later to explain how to find dx by dt and all. If x is given, if x is a function which varies with the time, how will you find the velocity? You just find the first derivative, d by dt. Some equations are there to study. So that equation we can study, children.
Using this numerical
What is this?
method.
Okay.
The position of a particle that moves along a straight line is defined by the relation x is equal to t cube minus 6t square.
Okay, problem we can do later, children. We will be doing, but later. So now I will take the note and explain. Notes I will take. Note was kept here, but it is not seen now. Okay, I will show. So now you go study the expression for instantaneous velocity. What is the expression, children? Tell. What is the expression? Limit delta t tends to 0. Complete it. Delta t tends to 0. Delta x by delta t. Or in differential calculus, what is the equation? Differential calculus. Mathematics, how it is represented? Limit delta t. Dx by dt. Very good. Dx by dt. First derivative of position with respect to time. First derivative of position with respect to time. Your page is in textbook also you can see that how they calculated the instantaneous velocity. Children, today you go through the textbook also. You can see that how they determine instantaneous velocity from graph. What is the direction of velocity, children? Vector quantity you told. What will be the direction of velocity? Tell. What is the direction of velocity? Velocity is displacement by time. So what is the direction of velocity? Why no one answers? This is the textbook page. Velocity's direction is in the direction of displacement. Very easy. Velocity's direction is in the direction of displacement. Anamika. Before you go, you have to give attendance, children. You have to remind me before you go. Okay, I will take attendance. Every day it's a problem taking attendance. So this you can see notebook how it is given. You can see instantaneous velocity. It is defined as the limit of average velocity as the time interval delta t becomes infinitesimally small. Oh, that is wrong. Textbook you can write definition is given infinitesimally small now. Infinitesimally small. So very very small. That means infinitesimally small. So limit delta t tends to 0 delta x by delta t, that is v equal to instantaneous velocity v equal to dx by dt, where dx by dt is differential coefficient of x with respect to time. It is the rate of change of position with respect to time. Differential coefficient of x d by dt means differential coefficient. Differential coefficient of x with respect to time. How we read this? What is the meaning of this? Differential coefficient of x with respect to time, or first derivative of position with respect to time. Different way we can explain this, or it is same as this one. So, in the language of calculus, it is dx by dt. Instantaneous velocity is dx by dt. Instantaneous speed. Instantaneous speed means it is the magnitude of instantaneous velocity. Speed is the magnitude of velocity. Speed. See, velocity is magnitude and direction. If you take the magnitude only, we get speed. So, if you find velocity, that is magnitude and direction. If you find only magnitude, that becomes speed. Speed plus direction is velocity. Speed plus direction is velocity. Without considering the direction, if we simply write the magnitude of velocity, that becomes speed. Same. Then some equations, I told differential calculus, some equations are there that you have to study before doing the problem related to it. Some problem textbook worked out problems are there, extra problems I also will give you and to make that idea clear. Okay. For that you must study this equation, that's important, and in coming chapters also some equations we need. So that also you have to study. Okay, I will explain those equations. Today after class you can study these equations. D by dx of, that means first derivative of differential coefficient of a into u. A is a constant here. U is a function which varies with x. U is a function which vary with x. A is a constant. In such cases, how will you find the answer? For that, a constant is not differentiated, it is always taken outside. A is taken outside the differential, and u is written du by dx. So, for example, I will give you problem. I will explain the equation now, and we will be doing problem. Then it will be easy for you. So, d by dx of a into u. You see, children, this is u and this is x. Different functions. Numerator it is u and denominator it is x. And a is a constant. So, d by dx of a into u equal to a into du by dx. Study this. Okay. Next, if a product come, d by dx of a product, for example, x into t or like that. If any product come, what you have to do? That means first into, this is first, this is second. First into derivative of second. First into, this is first into derivative of second, dv by dx, plus second into derivative of the first, second v into derivative of the first, du by dx. So, when a product come, d by dx of differential coefficient of u into v. When a product come, what will you do? First into derivative of the second plus second into derivative of the first. So, you tell first into u into dv by dx plus second into, that means v into derivative of the first, du by dx. This is the formula. This way you have to study. When a product come, how will you differentiate that? All of you are studying maths now, children? In your group?
Yes, miss.
Okay. Then no problem. Maths you will be studying, integration, differentiation, all you will be studying in detail in maths. We need only very few equations from the differential, we are studying 5 or 6 formula, but about 20-30 formulas are there in differential calculus. So many are there. But we study only what is required in our physics. Okay. So this is the equation for product. Then d by dx of sin x cos x, d by dx of cos x minus sin x. That is important. D by dx of sin x, it is cos x. D by dx of cos x, it is minus sin x. Another very important formula, this we use, that is d by dx of x raised to n if a quantity is having power. And you see, here it is x, here it is x. In that case, what is the formula? N into power, n into x raised to n minus 1. This is the formula we use. D by dx of x raised to n equal to n into x raised to n minus 1. So, as it is first time, you may find, oh, what teacher is telling like that, you may feel. Don't worry, and do problems, it will be okay. Next is all these formulas you have to study anyway. D by dx of u raised to n. The other one is x raised to n. X raised to n, nx raised to n minus 1. But you know, if this is x and if this is u, some change is there. The first part is okay, n into u raised to n minus 1. But as these two are different functions, this is u, this is x. In that case, we have to differentiate one more time that function u, du by dx. We have to multiply du by dx. First part is okay, n into u raised to n minus 1. But next we have to multiply with the differential coefficient of this function du by dx. At that time we will not write n, only u is taken, du by dx. Next one, derivative of d by dx of d by dx of e raised to u. That is no change comes e raised to u exponential function, no change comes e raised to u itself. And d by dx of log x 1 by x. In coming chapters, these formulas are needed. But here, when we find the velocity, we need only one or two formulas. Mainly, and I will show you mainly the formulas needed in this. When we find velocity, we need this one. We need first equation. We need d by dx of a into u, a into du by dx. A is a constant that we need, children. Next, we need these two formulas only we need now. D by dx of x raised to n, and x raised to n minus 1. Then you may think, then why all this formula, teacher? Because this is the beginning, and later coming chapters we may use one or other formulas. So now itself you study the formulas. Whenever it is required, we can study, we can take that from our memory. Okay. Instantaneous velocity. In terms of derivative, instantaneous velocity, delta t tends to 0, delta x by delta t dx by dt.